Vertical tangent lines. Vertical tangent lines is kind of a backwater topic of calculus, and it has to do with differentiability. So we're going to examine the concept of vertical tangents by working out a couple problems. Problem number one, for each of the following, find the points, if any, where the relation has any vertical tangent lines. And here we have g of x equals 4 minus the cube root of x. Well, to find a vertical tangent line, we need to do a couple things. The first thing we need to do is differentiate. So step one is differentiate. In order to differentiate this function, we're going to rewrite it in what I call calculus-friendly form. Here we have a radical form. We're going to write this in rational form. The cube root of x is x to the 1/3 power. Next, to differentiate, we have g prime of x equals, this 4 constant becomes 0 differentiated, and using the power rule, we have negative, this negative sign, 1/3, and we have x to the power of 1/3 minus 1. Well, 1/3 minus 3/3 is negative 2/3. So here we have x to the negative 2/3 power, and we're going to rewrite this back in radical form. And so we have in the numerator negative 1, and this x to the negative 2/3 power will come down in the denominator as the cube root of x squared. And so the next step we have is to set this denominator equal to 0. And so when we set this denominator equal to 0 and solve for x, we will have essentially what x cannot be, because we cannot divide by 0 in math or in algebra. And so if we just undo this thing, if we cube both sides, we're going to have x squared equals 0. If we take the square root of both sides, we'll have x equals 0. So there is a vertical tangent line at x equals 0. And find the point. Well, to find the point, we have 0 is the x value of that point, and if we plug into the original function here, g of x is 4 minus cube root of x, we're going to just end up with 4. So 0, 4 is the point where there is a vertical tangent line. And here is the graph of this. We see a vertical tangent line at x equals 0. And the importance of the concept here is differentiability, because this function is not differentiable at x equals 0 because of the vertical tangent line. Next problem. H of x equals the square root of quantity 16 minus x squared. You might recognize this as a formula for a circle, or rather a semicircle, but we're going to do the same thing we did earlier, and that is rewrite this function in what I call calculus-friendly form. So we have to the 1/2 power, the radical becomes to the 1/2 power, and we have a chain rule application because we have in the square root place we have a 16 minus x squared. So h prime of x, we take the 1/2 exponent here and put that out front, and we have 16 minus x squared. 1/2 minus 1 will be negative 1/2, and simplifying or rewriting back in radical form, we have 1 over 2 times, I did forget something here. we have to also multiply, using the chain rule, by what's in the derivative of the inside, which is going to be negative 2x. So we have negative 2x. These cancel here, and we still have a negative out front, so we have negative x, and we don't have the 2 here any longer, and we have 16 minus x squared. So again, we take our denominator, set that denominator equal to 0, so we have the square root of 16 minus x squared equal to 0, and squaring both sides, we have 16 minus x squared equals 0. We can add x squared to both sides, so we have 16 equals x squared. So in this case we have x is equal to plus or minus the square root of 16, which is 4. And so what this really looks like is if we have a half circle here at negative 4, positive 4, and it goes like this, and our vertical tangent lines will occur right where x equals negative 4. You see a vertical tangent line here, and at x equals 4. X equals negative 4 and x equals 4. So, basically, this last graph I'm showing you is of a piecewise function of two half circles placed together, where between them, here at x equals 3, so we could say that this would be a piecewise function, maybe the square root of 9 minus x squared when x is less than or equal to 3, and down here we would have this negative 9, square root of 9 minus quantity x minus 6 squared when I'll put comma, x is greater than 3. So as a piecewise function, there would be a vertical tangent line right here where x equals 3. So this is kind of a backwater topic of calculus, but one that has to do with differentiability. And I hope this short video lesson has been helpful to you. Thanks.